Okay, so the first question says the probability density function of a new weight in pounds of a package, of a new weight of a package is given by the function f of x equals to 2 for x between 49.75 and 50.25. Determine the probability that a package weighs more than 50 pounds. So for question 1, f of x is 2 and x is between 49.75 and 50.25. And x is a continuous random variable. And what is the probability that the package weighs more than 50 pounds? The probability that the weight of a package, which is our random variable, is greater than 50 pounds. So if I want to calculate that, like other examples that we have done in videos, this is integral from 50 to upper bound, which is 50.25, f of x dx, and f of x is 2 dx. So that's 2x from 50 to 50.25. And if you put the numbers, when I replace the upper bound, that's going to be 100.5 minus 100, and this is going to be 0.5. So with a chance of 50%, the weight of a package can be greater than 50 pounds. The second question says, the second part says, how much chemical is contained in 90% of all packages? Meaning that, what is the probability that with the chance of 90%, you can say that the amount of weight, that the weight of a package is greater than this specific value. So what would be the specific value such that we can say with the probability of 90%, every package has a weight greater than this value. It says how much chemical is contained in 90% of all packages. If we pick any package, what would be this weight, this lower bound, such that we say that with probability of 90%, the weight of the package is definitely greater than this number. So that is probable. So if you want to calculate this probability, it's going to be integral from x to upper bound, which is 50.25, f of x, d of x, so that's x, 50.25, f of x is 2 dx, and that's going to be 2x from x, 50.25, and that's 100.5 minus 2x, and that, as we said here, this probability is supposed to be 0.9. And if you do these calculations, you will find the value of x such that 90% of the packages have a weight greater than this number. Okay, I don't know what is the value of x, but just do the calculations and then you find the value of x that can satisfy this expression. Any question? Okay. Let's go to version 2. The distribution of x is approximated with triangular probability density function f of x equals to this for x between 30 to 50, and f of x equals to this for x between 50 and 70. So here we have a special scenario which we haven't had before. So the probability density function is actually, it has two functional forms. So one of them is this. For every x, between 30 to 50, and then for every x between 50 to 70, the probability density function is this function. Okay, so far pretty much all the examples that we had, we just dealt with one, for example, function for a specific range for the x. But here, the value of the x can change between 30 to 70, and in this range, for the time that x is between 30 to 50, we use this functional form, and if the x is between 50 to 70, we use this functional form, and that's absolutely okay. We have just two different functional forms for the probability density function of this random variable, and that's perfectly fine. The question, part 1, says, what is probability of x less than or equal to 40? Okay, so first of all, let me ask you this. Is this equal to probability of x less than 40 or not? Is this correct? We are talking about continuous random variables. In continuous random variable,
Yes.
yes, so in continuous random variables, always probability of x less than or equal to something is the same as probability of x less than something. If I say probability of x, for example, is greater than 50, that's the same as probability of x greater than or equal to 50. If I say probability of x, for example, is between 35 and 65, that's the same as me saying probability of x less than or equal between 35 to 65, or the same, or all of these are the same. No matter if I write it as less than or less than equal, or I just less than equal for one of them, all of these are the same. And this is the case only and only for continuous random variables. Okay, so that's the case only and only for continuous random variables. If we are looking at discrete random variables, these relations do not hold anymore. Okay, so pay attention. For discrete random variables, these equalities do not hold. These two are not equal for discrete random variables. These parentheses are not equal for discrete random variables. So these equalities hold only and only for continuous random variables. So pay attention to that, keep that in mind. Okay, now let's go back to part 1, where we are asked to find probability of x and less than or equal to 40, and we just said since this is continuous random variable, this would be equal as if I would write it probability of x less than 40. Okay, however, so here 40 is the value that falls in the first range for the random variable x. So if I want to find this probability, I have to use this probability density function. So that is equals to integral from lower bound, which is 30, to x, to 40. So the upper bound is 40. F of x, which we just said is the top one, dx. And if we find this integral and put the values of 30 to 40, that will give us the value for this probability. Okay. The next question says, what is probability of, let me change the color in case it's better. The probability of 40 less than x less than or equal to 60. And I just told you I can potentially write this in any one of these forms. So I can put the equal sign in any place or just not put it at all. It makes no difference. Anyway, so to find the value of this probability, I'm going to look at the possibility that x takes a value between 40 to 60. However, here pay attention that 40 starts in the first range for x, and then 60 is here in the second range. So in other words, if I want to write it based on these two ranges I have for the x, this is probability of x between 40 to 50 to cover this part, plus probability of x between 50 to 60 to cover this part that falls in the second range. And if I want to calculate both these probabilities, so for the first one, when x is between 40 to 50, this is the range of the x, so I have to pick the first function. For the second part, when x is between 50 to 60, this is the range of the x, and I have to pick the second function. So for the first part, then this is probability of x between 40 to 50, the first function, which is 0.0025 x minus plus this is the second function. If we calculate both these, if we calculate these integrals and add them together, and then we are able to calculate this probability. And these integrals are simple. You can just calculate the integral quickly, replace the values for the lower bound and upper bound, so you will find the final value right away. But all that matters is that you are able to just read this probability correctly and see how you can write this probability based on these two possible range for the random variable and these two possible form for the density function. Okay, then the next question says, what is value of x exceeded with probability 0.99? What is the value of x that we can exceed with probability of 0.99? So x has the random variable x has this distribution that we have specified here. So what is the value for this random variable such that any random variable that we pick is going to exceed this value with probability of 0.99? We want to find this lowercase x. We want to see what is that number. Okay. So since this is 0.9999, that's almost 1. So I expect this number, this random variable, this value x that we are looking for is somewhere in the first range for the random variable x. So what I'm going to do here is to basically say that this is probability of going from x to the upper bound. And upper bound for this random variable is 70, right? So this random variable goes from 30 to 50 and then 50 to 70. So the upper bound for this random variable is 70. And I want this probability density function, whatever it is, d of x to be 0.99. However, I know that I can write this from x to 50, and for this range I'm going to use this probability density function plus for the rest of the values for the x is going to go from 50 to 70, and for the x when x is between 50 to 70 it's in this range, and I'm going to use this density function. And if we calculate this, the value of these two integrals, so basically this is what we try to calculate, right? And this is the equivalent, and then I wrote this equation based on these two parts, and this is equals to 0.99, or it's supposed to be equals to 0.99. Our goal is to find the value of x such that when we calculate these two integrals and add them together, we get 0.99. And if we calculate the integrals, put the values, upper values and lower values, and put it equals to 0.99 and solve it for x, we are going to find the value of x, which is going to be the value where our random variable is going to get a value greater than this with the chance of 99%. Any question, guys?
No.
Okay. The next question, the next part, it says, what is CDF, the cumulative distribution function? The probability of random variable x is less than or equal to x. We also show it by uppercase x. And if the probability density function, lowercase f of x, has two possible forms, when x is in this range and when x is in this range, my probability density function is going to be similar to that as well. So for the probability density function, I'm also going to have similar things. So I will have one probability density function for the time where x is between 30 to 50, and I'm going to have another time for the scenario, and I'm going to have another one for the scenario when x is between 50 to 7. Okay, so let's calculate that. So I want to calculate f of x, or probability of x less than or equal to x when x is between 30 to 50 for the first range. In that scenario, I'm going to write it as from the lower bound, which is 30, to this value of x, f of x, which is 0.0025 minus 0.0 dx. Okay, so this has x. So this, for example, if we do the calculations, this is going to be 0.0. And we have to put this lower bound, this lower bound and upper bound. And when we do these calculations, whatever is going to come out when we do these calculations, whatever is going to come out is going to give us the probability density function for the time when x is between 30 to 50. And I'm going to call whatever is going to come out, I'm going to call it as function 1. So we are going to write that here. For the time that x is between 30 to 50, this is going to be my cumulative distribution function. So whatever is going to come out of this, I'm going to put it here. How about for the second one? When I want to calculate f of x or probability of x less than or equal to x when I know that x is between 50 and 70. So what is the probability density function when x is in this range? So for that, I'm going again so I know the lower bound for, so the x is in this range, meaning that this x that is going to sit here is in this range. Okay. However, the random variable x itself starts from the lower bound 30 the random variable itself starts from the lower bound 30 and goes all the way to x, and we want to calculate f of x d of x, and that is going to be from 30 to 50 plus dx plus from 50 to x, that's the lowercase x, and okay. If I do the calculations, solve these integrals and put the lower bound, upper bound, lower bound, upper bound, whatever we are going to get, I'm going to call it as 2, function 2. That's the result of the cumulative density function when x is between 50 to 70. And that, whatever I'm going to come up with, that whatever is here is what I'm going to put here for the time when x is between 2 to 70. So my cumulative density function or CDF will have 2 possible options similar to the probability density function that we saw on the top. One is for the scenarios when this x is between 30 to 50. The other one is for the scenarios when that x is between 50 to 70. So that will give you the probability density function. Any question? Okay. Let's go to question 3. The volume of a shampoo filled into a container is uniformly distributed between 374 and 380. So this random variable x shows the volume of the container, the shampoo container, and is uniformly distributed between 374 and 380. What are the mean and standard deviation of the volume of shampoo? So this x has uniform distribution, so this is A and this is B. Can you tell me for a uniform random variable that changes between lower bound A and upper bound B, what is the formulation for average of x or mean or expected value?
Those two numbers added divided by 2.
A plus B divided by 2. So that's going to be 374 plus 380 divided by 2, which I believe is going to be 377. And what is the standard deviation? So a standard deviation is the square root of the variance. So variance of x is going to be b minus a to the power of 2 divided by 12. That's 380 minus 374. That is 3. And standard deviation equals to square root of the variance is square root of the 3. What is the probability that the container is filled with less than the advertised target of 375? What is the probability that the container is filled, the volume of the shampoo in the container is less than the target or the advertised target of 375? So that is integral from the lower bound, which is 374, to this value of x, 375, f of x, d of x. So tell me, and this f of x that I put here is probability density function, right? So tell me, for a random variable x that has uniform distribution between a and b, how do I write the probability density function, or f of x? How do you write that? You have this in the slides and in the videos and in the quizzes. Like, how do you write that? The formula is 1 over b minus a. So 1 over 380 minus 374. That's 1 over 6. So then this calculation is from 374 to 375, f of x, which is this, 1 over 6 d of x. So the result is going to be 1 over 6. If you do the integral, put the lower bound and upper bound, this is what you're going to get. What is the volume of the shampoo that is exceeded by 95% of the containers? So what should be the volume such that for any x, for any container that we pick, the volume of the container is greater than this value with the chance of 95%. What is the volume of shampoo that is exceeded by 95% of the container? So if you pick any random shampoo or random container with the chance of 95%, we can say that the volume of that shampoo is greater than this number. So we want to know what is this number. So this is going to be integral from x to the upper bound, and upper bound we know is 380, f of x, which is 1 over 6 d of x, and that's, we want this to be 0.95. So this is going to be 1 over 6x from x to 380, or 380 minus x divided by 6 equals to 0.95. And if you solve that, you will find the value of x that can give you what you want. So this value of x is the volume of shampoo, where we can say 95% of the shampoos have a volume greater than this number. And then the last part says every milliliter of shampoo costs the producer $0.002. So this is the money that the producer pays for every millimeter of the shampoo they put in these containers. Any shampoo more than 375 millimeter in the container is an extra cost to the producer. So the weight that we want, or the volume that we want, is 375 millimeter. And any volume greater than this is a cost to the company. So we want to see what is the average of extra cost. What is the average extra cost for each shampoo? How do you think we have to calculate this, guys? Any idea? So the average cost obviously depends on how many more millimeters we have in every container, in every shampoo, on top of what is the target, what we want. So this is the target, right? However, if we pick any typical shampoo container, on average, this shampoo container has the volume of this shampoo container is 377 millimeter. So on average, for every container that we pick, we expect the volume of the container to be 377 millimeter. However, the target is 375. So for each typical shampoo container that we pick, we expect to have 2 millimeters extra volume, and 2 millimeters extra in the volume of the shampoo, and for each millimeter we pay $0.002. So the result is going to be $0.004. So this is basically the cost that the company is paying on each shampoo that they are producing, because the average volume of the shampoo is 377. However, the target value is 375. So they are paying a little cost on these extra fillings that they do, and that cost is $0.004. Any questions so far, guys? And so we're going to go to question 4. An electron emitter produces electron beams with changing kinetic energy that is uniformly distributed between 3 and 7. Suppose that it is possible to adjust the upper limit of the kinetic energy. So our random variable is the energy level. And this random variable has uniform distribution between 3 and 7. Continuous uniform distribution between 3 to 7. The question is, what is the mean kinetic energy? Okay, so what is mean or average or expected value of x? This is my lower bound A, this is my upper bound B. So average of x is a plus b divided by 2, 3 plus 7 divided by 2, that's 5. What is the variance of x? We already calculated the variance of another uniform random variable a couple of questions before, so you can easily calculate that, so I'm not going to repeat that again. What is the probability that an electron beam has a kinetic energy of exactly 3.2? The probability that x, the energy level for a specific beam, is exactly 3.2. What is that probability, guys?
0. Right?
Is this clear for you guys, all of you? So for a continuous random variable, this is important that you guys know, okay? These are the basic definition or the basic concepts related to continuous random variables. For continuous random variables, probability that x it's going to take a specific number is always 0, because when we say that x is going to change between 3 to 7, basically there are infinite possible numbers in this range from 3 to 7. These are all real numbers, right? Between 3 to 7, there are just infinite possible numbers. Now you pick one and you say, oh, what is the chance that x is equal to 3.2? It's just that probability is almost 0, because there are just infinite possible numbers. What are the odds that you just can exactly pick this specific number? Okay, so that for continuous random variable, always probability of x equal to something is 0. So that's the very basic concept that you have to know about continuous random variables. So if in the exam there is a question like this and you guys get it wrong, so that's an F for the whole exam, because this is the basic of continuous random variables. If you don't know this, then you basically know nothing about continuous random variables. So make sure these very basic definitions of continuous random variables are clear for you. So so let me explain this thing. We have two scenarios, right? So I can tell you x is a continuous random variable, has uniform distribution between 3 and 7. Okay, so that's one scenario. In the other scenario, I can tell you x is a discrete random variable, and x has also a discrete uniform distribution between 3 and 7. Okay, so this is A, this is B, this is A, this is B. One random variable is discrete, which we learned in module 2. One random variable is continuous. Okay. And I'm asking you, what is probability that x equals to 4? What is the answer to this question in this scenario when x is a continuous random variable? Do you guys not know the answer, or you just don't feel like answering?
0.
This probability is 0. For any continuous random variable, the probability of x equal to something is always 0. However, what is probability of x equals to 4? Is this 0 for this problem as well? Is this correct?
I want to say yes.
Why?
I'm not too sure.
So,
actually, it might not be because it's discrete, so I think maybe it only equals zeros when it's continuous.
The probability of, yeah, so the probability of x equals to 4 is only 0 when x is continuous random variable. Why? Because as I said, in the range of 3 to 7, there is infinite possible value for random variable x. So the probability that x is going to be exactly 4 is almost 0. But if it's discrete and varies between 3 to 7, what are the possible values that x can get? Is 3, 4, 5, 6, 7. So the x can get only 5 possible values. So then we can definitely say probability of x equals to 4 definitely has a value, and we are going to find what is that. So if it's discrete, this probability is a valid probability and has a value. If x is continuous, this probability is always equals to 0. So now tell me, for a continuous uniform random variable, what is f of x? What is the formula for f of x, which is probability density function? Go ahead. The formula is in the slide, was in the video, and you guys should know this to be able to answer the homework and the quiz. So the formula is 1 over...
You want to say?
What?
1 over b minus a?
1 over b minus a, which is 1 over 7 minus 3, which is 1 over 4. Okay? So that's the probability density function for this continuous uniform random variable. However, in the scenario when x is a discrete random variable, what is the probability mass function? F of x equals to 1 over b minus a plus 1. So this is going to be 1 over 7 minus 3 plus 1. That's 1 over 5. Okay? So pay attention. Both of these are uniform random variables, but both of them are in the same range, 3 to 7. But one of them is continuous, one of them is discrete. They have different probability function. The probability density function for the continuous random variable has a different form than the probability mass function for the discrete random variable. And what does this probability mass function means? It means the probability that we pick any one of these numbers, right? So for the uniform random variable, the definition of uniform random variable is that all these possible values for x have similar probability, right? So all I have to do is to find out what are those possible values and then just give the same probability to each one of them. So between 3 to 7, what are those possible values? Count them with fingers. 1, 3, 3, 4, 5, 6, 7. So between 3 to 7, the random variable x can get one of these 5 possible values, right? So, and if all of them have the same probability of happening, so that means each one of them has the chance of 1 over 5 of happening. And that's exactly what we came up with here. If I just say 1 over b minus a, what I get is 1 over 4. That's why we always add this plus 1 so that we can have it correct. But this is 1 over 5 because between 3 to 7, there are 5 numbers, not 4. Okay, so that's why we always had this 1 plus 1 here to have the correct part. And then, so given that, can you tell me what is this probability? Probability of x equals to 4 if we know that x is a discrete uniform random variable. What is that? X equals to 4. One of this is going to happen. What is that probability? I calculated the probability mass function here. Guys, what is the definition of probability mass function? That's probability of. Can someone tell me what does this mean?
Then it's just 1/4 or 1/5 chance.
That's probably, so when I say f of x, that's probability that the random variable equals to x. So when I write f of x, that's probability that the random variable equals to this green x. And here I set this probability equals to 1/5. No matter what the x is. I know the possible values of x is anything between 3 to 7, and those are 3, 4, 5, 6, 7. But f of x is 1/5 for all possible values between 3 to 7. That means f of 3 is 1/5, f of 4 is 1/5, f of 5 is 1/5, f of 6 is 1/5, and f of 7 is 1/5. Because what does f of 3 means? Probability that x equals to 3, probability that x equals to 4, probability that x equals to 6, probability that x equals to 7. And we just said here, all of these probabilities are the same, and all of them are 1/5. So probability of x equals to 4 is f of 4 is 1/5. Okay? When you are working with a uniform random variable, make sure to read the question carefully and figure out if this variable is a discrete variable or is a continuous variable, because each one of them has a different form for the probability function, and for some of them, some probabilities make no sense. For some of them, some probabilities make a lot of sense, and so forth. So now that we are here, let me ask you another question. For this same problem, probability of x less than or equals to 5. Is this correct? Is this expression correct? X
Yes.
is continuous. Can you repeat one more time, sir? The answer was?
Yes.
Okay, yes, because, can you tell me why? Because this is a characteristic of every continuous random variable. For every continuous random variable, the equality here does not matter. So that's what I believe I mentioned here. No. Here. We just said a couple of minutes ago. All these probabilities are the same. It doesn't matter if I put less than or less than equal, like all of these are the same, right? And only because this is a continuous random variable, we just said that. And here, if x is a continuous uniform random variable, this equality holds, because for every continuous random variable, no matter what type of distribution they have, if it's continuous, if it's normal or whatever, always, it doesn't matter if you put equality or not, or just put less than or greater than equal, it doesn't matter. And can you tell me how do you calculate this probability? for this continuous random variable, uniform random variable? That's integral from lower bound, that is 3, to upper bound, that is 5, f of x, which I calculated here, f of x is 1 over 4 dx. So this is x over 4 from 3 to 5. The result is 0.5. If you do the calculations, the result is 0.5. Okay. So these are all for the scenarios where x is continuous random variable. Now let's go back. Let's look at the scenarios when x is a uniform random variable but it's discrete. Now tell me, for this scenario, is this still correct? X here is a discrete random variable. Can I still say that this is correct? Similar to what we said for a continuous random variable?
No,
Why?
because each one of the values has a different probability.
So what? Okay, so when I say x less than or equal to 5, probability of x is less than or equal to 5, what are the values I'm considering? Probability of x equals to 3, right?
Yeah.
4 and 5. But how about this one? Probability of x less than 5. What are the values that I'm considering over those in that scenario? X equals to
4 and 3, so
and 4.
Mm-hmm.
So this probability obviously is going to calculate probability of x equals to 3 and 4 and 5. This one is going to calculate probability of x equals to 3 and 4. So I can always say that these two are not equal. So what is the relation between them? This probability is always greater than or equal than this other probability, because we also add the probability of x equals to 5 to this one. So this probability is greater than or equal to this one. I put equal because just to be on the safe side, like what is the worst case scenario if this is 0, the probability of x equals to 5 is 0, the both sides are equal. So I always say probability of x less than or equal to 5 has all these three values, and this probability is always greater than or equal to this other probability. Okay, so make sure to pay attention to this part. So these concepts that we are talking about right now, these are not hard concepts, right? So this is a simple uniform random variable between 3 to 7, right? So you have all the formulas and everything to calculate, but I want you guys to understand the concepts. The huge difference if x is a discrete random variable compared to the scenario when x is a continuous random variable, and how for some of the relations are different between these two different random variables. This probability here is 0. This probability here is a very valid number. You know, so this equation holds here. This equation, this is how it holds in a discrete scenario. So make sure to pay attention to what those mean. Any question, guys? Okay. If no question, let me go to question 4. electron emitter produces electron beams with charging energy that is uniformly distributed between 3 and 7. So the X, which is the energy of the beams, is uniformly distributed between 3 and 7. Suppose that it's possible to adjust the upper limit of the kinetic energy. What is the mean energy? So we pretty much have solved most of this. So what is the average of this random variable? We already have calculated that. What is the variance of X? We already have calculated that for another variable, so I'm not going to repeat it. What is the probability that an electron beam has a kinetic energy of exactly 3.2? The probability that an electron beam has an energy of exactly 3.2. What is the answer to this question? All of you have to say it in no time.
0, because this is continuous, right?
0, because this is continuous. These are the mistakes I'm not going to ignore in the exam, guys. These are just the basic definition of continuous random variables. Probability of X equal to something, if X is continuous, is always 0. What should be the upper limit so that the mean kinetic energy increases to 8 joules? So it says the upper limit here apparently can be changed. So it says what should be the upper limit if we want the mean or average of the energy goes to 8. So the average of the energy here in the original scenario is 3a plus b divided by 2 is 5, right? Now I want this random variable to have the lower bound of 3 and upper limit. I don't know what it's going to be, but I want the average to go to 8. So I want the average of this random variable to go to 8. So what is the upper bound that can give me the average of 8? Just do the calculation, and A is going to be 13. So the upper limit of this random variable should go from 7 to 13. What should be the upper limit so that the variance decreases to 0.75? And just do the similar calculations. Variance of X is B minus A, which is 7 minus 3 to the power of 2 divided by 12. I believe that's going to be 4 over 3 or 1.3. And we want this variance to go to 0.75. So what should be the upper limit? Again, I want X to start from 3, but I don't know what should be the upper limit such that the variance is this value. So I'm going to calculate the new variance, which is B minus 3 divided by 2 divided by 12, and I want this variance to be 0.75. Do the calculations, and then you're going to find the value of A that is going to give you that. This is simple, so not much time. Before we, any questions so far, guys? Before we go for the normal random variable, that's easy, right? So for normal random variable, all we need to know is that it has normal distribution with some average and some variance. For example, X has normal distribution with average 10 and variance of 4, let's say. And if I want to ask, okay, what is the probability that X, this random variable, gets a value greater than, let's say, 12? How do you calculate this probability? Do you guys know how to calculate this probability? So we have to translate this normal random variable to a normal standard. So how? By deducting the average and dividing it by the standard deviation. So this greater than 12 minus 10, the average is 10, divided by standard deviation, which is 2. So that's going to be the probability that this is z greater than, so 12 minus 10 divided by 2 is 1. So how are you going to find this value? Do you know how to find this value, guys?
The chart? From the chart?
From the chart. So, however, if you look at the charts that are on Blackboard on the same module, the Z value charts, you see those charts. If you look at the top page of those charts, this is what you see, right? It's something like this. Do you see the same thing? It shows a normal distribution and it shaded the area on the left. So it says Z and it shaded the area on the left, right? So that means those probabilities that you see in the table are probability that random variable Z is less than this value or less than this. Okay, so these type of properties are going to be returned by the table. However, what I need here is something like this, probability of Z greater than something. If I had asked you probability of Z less than 1, yes, go to the table, find the Z equals to 1, and then give me the probability. That would be great. However, what I want from you here is probability of Z greater than 1. How can you give me that probability?
1 minus the value less than?
Exactly. So that's equals to 1 minus probability of Z less than 1. And then I'm going to get these from the table. So can you give me this probability from the table?
0.841345.
Z less than 1, yes, is 0.84. Is that what you said?
Yeah.
Okay. Z less than 1, if you look at the table, the Z table is 0.84. And then the result is 1 minus 0.84, which is going to be 0.16. Okay. So always make sure to pay attention. The probabilities that you get from the Z table are always in this form. And if you need something in this form, make sure to translate it to some probabilities that you can get from the table and then do the calculations and report the final value. Does that make sense? I want to also ask you, for this random variable, for the same random variable x that has new normal distribution average 10 and variance 4, what so let's assume this is the question. What is the value of the random variable such that 95% of so let's say this random variable is the weight of a package, average 10 pound and variance of 4. And I want to know what is the weight of a package such that 95% of packages have a weight greater than that value. Let's assume X is the weight of a package, average 10 pound, variance of 4. And I want to know what is the weight of a package such that I can say, what would be the weight value such that I can say 95% of the packages have a weight greater than that number. So what would be this lowercase x such that I can say all the packages, if I pick any package with random, this package has a weight greater than this number with a probability of 0.95. And I want to find this X. You know everything to be able to calculate this. Can you give me some idea on how you go about this calculation?
We change it to a normal distribution first.
We change it to a normal, to a normal standard,
Yeah, normal standard.
Z. So I say, okay, probability of X minus average divided by 2 sigma is greater than X minus 10 divided by 2, that's 0.95. So that's probability of Z greater than X minus 10 divided by 2 is 0.95. Okay, what else? Where do I go from here?
You could change the Z part of it to less than, subtract from 1.
This is my lowercase z, right? So what I want to do is to find out which value in the z table corresponds to this number here, such that this probability equals to 0.95. However, as we talked here, the z table gives me the values which are z less than lowercase z. So first, I have to transform or translate or change this left side to something that I can get from the table. So probability of z greater than lowercase z, I'm going to write it as 1 minus probability of z less than lowercase z. That's equals to 1 minus 0.95, right? So probability of z greater than lowercase z is 1 minus probability of z less than lowercase z. Sorry. That's 0.95. So I'm not going to change the right side. So I just wrote the left side equivalent to this, right? So as a result, probability of z less than lowercase z is 1 minus 0.95 is 0.05. Now I know probability of z less than, and my lowercase z is this what I wrote here. X minus 10 divided by 2 is 0.05. So now tell me how I'm going to find the, so basically here I didn't do anything. I just rewrote this probability that I had in a form that the table understands. So now tell me from this equation, how can you find the value of x for me?
Well, you find the 0.5 on the chart that corresponds to a z.
Let me stop here and share my. So this, you can see my z table, right?
Yeah.
So remember, so in the z table, the values that you see in the body of the table are the probabilities. So here the probability that I have on the right side of that equation that I wrote, probability of z less than x minus 10 divided by 2 is 0.05. So that probability is 0.05. So what I can do here is to come here and see if I find the probability of 0.05. Obviously, there are a bunch of them, like 0.0515, 0.052, but find the closest. to 0.05. So that's this one. This probability is the closest to 0.05. Obviously, it has 0.05, 0.03, blah, blah, but it's the closest to 0.05. Now, let's find out the z corresponding to this probability. The z corresponding to this probability is minus 0.64. Okay? So find the z corresponding to this probability, and that's minus 1.64. So I'm going to go back to okay. So this z is that minus 1.64 that we saw in the table, because in the table we saw that the probability of z less than this value was 0.05. So then I can say that this x minus 10 divided by 2 equals to 1 minus 0.64. That's the z value that I got from the table. And if we do these calculations, I can find the value of x. And that is going to tell me the value of x, or the weight, such that 95% of the packages have a weight greater than this number.